In this station, I'm going to talk to you about determining the organic matter content of a soil. There are different ways. One way is to estimate the organic matter content. This will be not an accurate method, and you will estimate based on the soil color. So we have two unknowns, unknown 1 and 2, and then based on the Munsell soil color chart, when I place them, these colors are matching, like a 10YR 5-3 color, and that is less than 2% organic matter area. And then as you go toward the lower values and then lower chroma values, then you get more darker color, so that represents more organic matter in the soil. So our unknown 2 is kind of has a 10YR 3-1 color, so that will be telling us that it has somewhere 3 to 5% organic matter. This chart is developed by the University of Illinois, and they also have the same color scheme for determining the organic matter. They provided the average value for each color and also the range for each color. So based on that, our unknown sample number 1 is also classified under the less than 2% category here. So that is like one way to estimate the organic matter content of a soil. We will talk about the next method. The next method to determine the organic matter content will be based on the dry combustion method. In this method, we are trying to burn all the organic matter from the soil, and based on the difference of the weight, we will be able to determine the organic matter content of the soil. So this is the field moist organic soils, and then we place that soil in the oven, and then this is the oven dry soil, and then finally we place the oven dry soil in a under high heat, and then all the organic matters are burned off, and we left with the soil here. So all of these has the jar weight, so we need to remove the jar weight first. So that is counted 0 right now. And then we will place the field moist organic soils in that weight around 157.6 gram. Next, we will determine the oven organic soil in that weight around 46.1 gram. And then we have the ash soil weight, and that will be around 15.7 gram. So based on these differences, you will be able to determine or calculate the amount of water that's stored and also the amount of organic matter in the soil. So if you subtract the oven dry soil from the field moist and then divide it by the oven dry, you will get the amount of water in the soil, and you will be surprised that it has a lot of water in this one because it has high amount of organic matter. And then if you want to find the amount of organic matter, you subtract the ash weight from the oven dry soil and then divide it by oven dry soil, and that's how you determine the amount of organic matter. In this method, we are trying to determine the organic matter content based on the colorimetric method. So we will have 1 gram of soil that we will add 10 milliliter of the potassium dichromate, and then we will add 20 milliliter of concentrated sulfuric acid, and then we will add 100 milliliter deionized water. Once we get the filter, the samples are ready to be read in the spectrophotometer. So this is the blank sample. We need to do the calibration first. So the sample should read this is the blank, and it should read 100 transmittance. And then this is the Forstmann soil, and then the Forstmann soil has more organic matter. You can see that the soil color is darker than the Claremont soil. So our reading is 58. Every time when you're taking sample, you need to take it from the top so that you don't have your the oil from your hands does not stick to the cuvette. So you clean it and then you place it here actually. So but I did all of those steps before. And this is the Claremont soil, and it reads around 85 or maybe in that range. So what you do is, next step is, we have these charts developed so that you can transfer the transmittance of the wavelength to the amount of organic matter. So around 85 will be around like 1.5% organic matter, and then we have the other reading as well, so you can match it and then determine the organic matter content of the soil. One way to show you that organic matter has a bulk density of less than 1 will be through this demonstration, that we have water which has a bulk density of 1, so the peat should be floating on top of it on the surface, so it doesn't get merged into the water because it has a density of less than 1, which is the density of the water.